now we have to start with your unit number 4 that comprises of your chapter 8, which is gravitation. All right, so from NCERT, this is chapter number 8, gravitation. So basically, in this lesson, you have to consider two things. See, if a body is there which is having mass m1, another body is there having mass m2, and both the bodies, they'll be having certain force between them. We have discussed, when we were discussing potential energy, that time only we discussed that two objects, two bodies, when they are kept, if they interact with each other, they exert potential energy. It means if both the bodies, they have interaction in the sense as if they exert force on each other. So if they exert force on each other, this force we call it as gravitational force. Now, two phenomena are there which you have to study in the introductory part. One includes the Newton's laws of gravitation. Newton's laws of gravitation. And secondly, you have to study Einstein's theory of gravity. These are two topics that are included. Basic theories that are included in your introduction: Newton's law of gravitation and Einstein's theory. All right. So mainly we'll do Newton's law of gravitation only. One single law is there. Actually, in your 12th standard, you will see a similar law. So that's why I'm saying gravitation and electrostatics, which you do in class 11, those are very similar. So prepare gravitation well in here in class 11. So it will be helpful for you in class 12th also. And now after 2 to 4 months only, you have to appear for class 12th. So that's why. Prepare few topics of gravitation very well. Some are very different, but instead of masses, you will be having charges in class 11 or 12. So Einstein theory of gravity is also there. All right, so this is a general theory that is present. But we have to do Newton's law of Newton's law of gravitation. C class. If there is one body, mass m1, if there is another body having mass m2, both of these are separated by a certain distance, let's say r. Both of them can exert force on each other. Now see, this gravitational force that will exist between these two bodies, this will be, see, this gravitational force, this is firstly directly proportional to product of both the masses. Secondly, inversely proportional to square of the distance between them. Directly proportional to product of masses. And inversely proportional to, this is directly. And inversely to square of distance between them. Fine. Now, if you combine all the proportionalities, gravitational force will be directly proportional to m1, m2 divided by r square, because it is inversely proportional to this. Now, obviously, we all have been studying and we know the fact that whenever you have to remove the proportionality sign, you have to put an equal to with a constant. So here also we'll put an equal to with a constant. That will be g m1, m2 by r square. Now, this G is what? G is basically gravitational constant. This is a universal constant. It means it is independent of medium, independent of nature of material, independent of distance between the particles, independent of masses of the particle, independent of the potential energies of the particle. So G is universal constant. This is universal gravitational constant. Universal gravitational constant. So it has a specific value which you all have to remember, 6.67 into 10 to the power minus 11 Newton meter square per kg square. Fine. So this is universal. Universal means that this value, this is independent of medium. Why am I mentioning this point separately? Because you will be getting questions. The acceleration due to gravity will start with acceleration due to gravity, which we had done in motion under gravity in motion in a straight line. So same thing, that acceleration due to gravity varies with the planets, varies with atmosphere. For Earth, acceleration due to gravity is different. For Moon, it is different. For Jupiter, it is different. But gravitational constant, this is the universal, that is, it is independent of medium. On Moon also, you have this value only. On any other planet, Mars, Venus, Jupiter, you have this value, as well as on Earth also, you have this value. Now, one more thing, class, when you use this law, this Newton's law, make sure that this formula, this is valid only for point charges, not charges, sorry. Here we are considering masses. So point masses or spherical body. So this formula which we study, G m1 m2 by r square, is valid. This is valid only for point masses or spherical bodies. Fine. Also, remember one thing, class, we did in work, energy, and power, conservative, non-conservative forces. So do you remember what type of force was gravitational force? Conservative force or non-conservative force? Yes, conservative force or non-conservative force? Look, just turn your pages. At least you must have written it in your notes, the portion where we did work, energy, and power. In that only we have done. Just check. Aram was there, I think. Tarif was there. Abdullah was also there. Talha was there. Terim, you were also there, I think.
Conservative force.
Conservative force. Exactly. This is conservative force. Non-conservative forces are those dissipative forces like frictional force, viscous force we see in fluids. So these are dissipative force that generate heat. Gravitational forces do not generate heat. They are not. They are a conservative force, right? So conservative, non-conservative, we had studied. Not that dependent on the just the initial and final point. It didn't depend on the path covered. Whatever will be the path, force will be the same. So same thing, gravitational forces, conservative. Yes, Iram.
Ma'am, I have a question.
Yes.
Ma'am, over here, why do we rather take the square of the distance than just taking the distance?
This is actually done experimentally. So this was done by Newton. So when he did all these experiments, now taking two bodies, he performed lots of experiments. So under those, he observed that initially he could see graph that yes, force is inversely proportional to the radius. That was concluded by him. And he could see that it is directly proportional to masses. Then he took the products of masses. Then he took the quotient of masses, added the masses, out of which he could conclude that yes, it is only directly proportional to product. Same way, he wanted to derive how is it inversely proportional to r. Is it just f is inversely proportional to r, or square of r, or cube of r, right, or r to the power 4? It could be any. So when he did all the experiments, he plotted all the graph. One result that could just satisfy it was this only. So these experiments, this law, as well as the Coulomb's law, which you will see in class 12, I'm saying no, this is very similar. Here you have F is equal to G mm by r square. There you'll have K Q1 Q2 by r square. Study gravitation as it is. So all these results, like the Coulomb's law, which you will study, the gravitational force, which you have it right now, all these forces, these are done experimentally. That's why we don't have any derivation. We are just writing directly proportional. whenever in your physics, no, you don't have any derivation and you're just writing things directly proportional. Either you can prove them using dimensional analysis. Remember, we have done the question based on this only to find gravitational constants dimensions. So one way is that. Second way is you can directly assume that these are done experimentally. Clear, Iram?
Yes.
Okay. So yes, I was saying gravitational force is a conservative force. Okay. And why? What is this cause of gravity? So gravity is due to the curvature of space and time, basically. That you can understand, but cause of gravity, gravitation force exists because of gravity. That a gravitational pull of Earth is known as gravity. Okay, let's do one thing. Note it down here, then I'll tell you what is gravity. There only I'll tell you rest of the things about it. Acceleration due to gravity also I'll relate it with this formula. Note down all these introductory points. Okay, yes, one more thing, class. This R, no, that is measured. This is measured from the center of both the masses or the point charges. If it's a spherical body, then from the center. Even if it's a point charge, then point mass, sorry, from the center only. This is what is R. See here, calculate force between the masses. So, you know, here you will apply the gravitational law of Newton. So, gravitational force is G m1 m2 divided by R. So, Fg gravitational constant is 6.67 into 10 to the power minus 11 into 5 into 10 by 10 square. So 110 will cancel. So see, let's take it as 6 and it will be 30. So its force will be 30 into 10 to the power minus 12. Okay, note down this question. Yes, one thing I was telling you, gravity, no? Okay, note down this and we'll talk about gravity first. So gravity is what? Gravitational pull of Earth. See, gravitational forces are everywhere. Gravitational force will be in every part of solar system. Let's say gravitational force will exist between Jupiter and its moon. Gravitational force will be existing between the planet Earth and the Earth's moon. Right? Like, a gravitational force can exist anywhere between Sun and Earth, and all these gravitational forces are only there that make all these planets revolve and stay at this particular position. Right? So, see, but specifically, it's just like a name given to the gravitational force of Earth. Specifically for the gravitational force of Earth, you call it as gravity. You don't use the term gravity for any other planet. Right. So, this is gravitational pull of Earth. Gravitational pull of Earth is gravity. All right. Now gravitational force. See, gravitational pull of Earth. So here you are sure about one thing. What? That one of the mass is Earth. This at least you are sure of that. Yes, the one of the mass is Earth. So now see in the formula FGG M1 M2 by R square. Let's say some body is there on Earth. This is some body of mass, and Earth's mass is M, and the radius of Earth is capital R. So if you apply gravitational force for gravity, that is specifically if you apply it for Earth. See, one body will be small m, that we are not aware of. What is this? That can be any body present. One mass we are aware of, that is Earth. So gravitational constant, one mass, mass of Earth, another mass of body we don't know, and divided by radius of Earth square. Why? Because the separation will be the radius of Earth square. This is the gravity's formula. This is gravity of Earth. Now, acceleration due to this gravitational force. Acceleration due to gravitational force. See, acceleration's formula is what? Acceleration formula will be, see, F is equal to ma. So acceleration will be force by mass. Force by mass. Put the value G, capital M, small m by R square, and this small m gets cancelled. Acceleration due to gravity, which is represented by small g. This is capital G, capital M by R square. This is acceleration due to gravity. Here, capital G is the constant. This is the universal constant. Capital M is mass of Earth, which is 6 into 10 to the power 24 kgs. And this is the radius of Earth, which is 6.4 into 10 to the power 6 meters. Now, if you substitute all these things in the formula, all these values, then you get the formula which with the value which is known as 9.8 meter per second square, which now we have been using in the lesson, motion in a straight line, also projectile motion, and all these things. Okay. Fine. So this is 9.8 meter per second square. This is the acceleration due to gravity's value. This is how the value of acceleration due to gravity is calculated. Now see here in this formula, you have here gravitational constant. You have mass of Earth. You have radius of Earth, which is fixed. You do not have mass of the body. You do not have shape of the body. You do not have any size of the body. So this shows that small g, this is independent of all these things. Independent of mass of body, shape of body, and size of the body. And this value is already constant, which is 9.8 meter per second square. We'll see details on this acceleration due to gravity later on. Firstly, we have to do one very important thing. This formula we have studied, Newton's law, that is G m1 m2 by R square. But if there are multiple masses, then how will we handle? That we have to do, because you will get questions where more than a single mass will be given. Note it down, then we'll see that. T class. For that purpose, which I was mentioning you, suppose let's say this is one body. Let's say the mass of the body is m naught. And there are other bodies as well. M1 body is there, M2 is there, M3 is there. All these are present. Now I just know the formula that includes only two masses. Either I can take M1 M2 or I can take M1 M0. I can take M0 M2 or M0 M3 or M0 M1 only. Out of these only I can take. But if I have these systems, I cannot neglect other gravitational effects that are occurring on the other bodies. In this way, in this case, what you do, take the separation from the first body. Take the separation of the, this is my reference body right now. I'm calculating the gravitational force on this because of other masses. Let's not take this M3, let's take it as Mn. So this becomes Rn. N means n number of bodies. All right, always use superposition principle for two or more point masses or spheres. Fine, always use it. Now, see if I calculate force between M0 and M1, that is 401, force between this. So that will be G M0 M1 by R1 square. That's how we apply the gravitational force. That's what we have studied. If I take the force between second one, and force is a vector, so vector sign. So it will be G M0 M2 by R2 square. Individually, if I calculate, F0 N if I calculate, for nth, N means N number of bodies are there. And N can be any number, 5, 4, 8, 100, infinity, any number. It will be G M0 Mn by Rn square. But I have so many masses. Now, how will I get the final mass? You'll get the final mass by vectorically adding all these. Net force will be vector addition. You all know parallelogram law, you know triangle law, you know Cartesian plane. Also, you know how to subtract like this. You will add all the forces up to n. That is, this principle is known as superposition principle. And class, this is a very helpful principle if quantities are vector. And this is not just valid for gravitation. In so many lessons, in so many physical quantities, you can use superposition principle when valid. So let me write down the statement for it. For a system of n interacting point masses, n interacting point masses, net force on a given mass is vector sum. Please, class, do not just add it simply. Vector sum means you have to consider angle, you have to consider direction, you have to obey the proper vector laws. Not just algebraic sum, it is vector sum. Vector sum of forces due to individual masses. Due to individual masses. Like, let me give you an example. Wait. A triangle is given, force on point mass. this, let's say this point is A, this is B, this is C. So centroid means this point. This is M kept here. So this is distance R is mentioned. And this is an equilateral triangle of sides A. So see, how will we calculate? And there are point masses that are kept. There are point masses that are kept of mass small m at the vertices of the triangle. These are the things that are mentioned in the question. I have not mentioned, but they are a part of question only. Now see class. Forces will be what? See, one force will be between these two. One force will be between these two. One force will be between these two. If I write FAO, let's say the center is O, FAO means this is mass M at vertex A. Here you have capital M at centroid O. Separation is R. How will we apply the formula? Yes, Yusuf. Apply the gravitational forces formula. One mass is given, second mass is given, separation is given. What will be the gravitational forces formula? Talha. Talha. Try at least, start with it, then I'll help you. Abdullah, gravitational forces formula. You have written it in your notes. Check your notes. See what will come. Yes, Abdullah.
M1 M2 by R square.
Yes, G M1 M2 by R square is the formula. So G I have written. What is M1 between here? Take any as it as M1 and take any as M2. So what should I write here?
Yeah.
See, one mass is small m, second mass is capital M. So capital M into small m divided by what is the separation between these two, Abdullah?
R.
R. So it will be R or something else.
Yes.
R square.
R square.
Yes. Okay. Good. Good, Abdullah. Then you have FBO, force between these two. Now, can you try? Other students who couldn't respond, Talha, Yusuf. Talha, can you now try? For these two.
G M
Correct. Now?
G M G M into M by R square.
By R square. Correct. It will be exactly the same. This FCO will also be exactly the same. G capital M small m by R square. Do you see all of these three have the same magnitude? Understood? Then you have to find out the net force. Now see, if all the forces are same, let's just take all the forces as F only. If all the forces are same, right? All the forces are same. See, now this is not a part of gravitational question. Gravitational question was at this point only, till this point only. Now see class, you just have to focus here on your vector laws. One vector is going here, F, one is F here, one is F here. Centroid, angle between the centroid of the triangle is 120 degree. Then only, no, this will be 120, this will be 120, and you will get your final answer as 360, the complete circle. This you know now. And all these forces F1, F2, F3 are equal to F, right? We have just seen all the magnitude is same. See, if two forces are F, so F prime, let's say what will be the net resultant? So A square plus B square plus 2AB cos theta is the parallelogram's law formula. So f square plus f square plus 2f square into 120 degrees. So that will be minus half. So 2 gets cancelled. This becomes 2f square minus f square. That becomes only f square, which is equal to f. It means the resultant between these two f's, will be here with the magnitude f only. Now see, both these forces are in opposite direction, this force and this force. So f net will be f minus f, which is equal to 0. So net force is 0 for this particular question. Clear? How did we solve this? This page is clear to all of you? Yes, no, what? Clear?
Yes, miss.
Okay. Okay. So this was superposition principle. Fine, note down the principle as well. C class. This question says that you have 2-point masses, small m and capital M. So you have small m and capital M, and they are separated by the distance small r. And now the force between them is F. So F will be G capital M small m by r square, using the formula, using the data that is given. Now it says if a point mass 3m, this is placed next to m, what will be the force on capital M due to small m? And what will be the total force on capital M? It means this is basically like, this was the first case given. Now, secondly, you have M and M on one side, and then you have capital M and R. So instead of this, it's better if we write this as 4M and this as capital R, right? Now see what will be the new force, F dash. This will be G. One force is 4 small m, second force is capital M divided by R square. Now see, force on capital M due to small m will be this. Now total force will be, for total force, just take the ratio of these two forces. Total force, take the ratio. F by F prime, take it. So F was G capital M small m by R square, and F dash is G for small m capital M by R square. Capital M got cancelled, capital G got cancelled. So F dash came out to be 4 times the earlier force. Like this. So direct comparison questions can also be asked to you, and questions in such manner also can be asked. Note it down. If you have any doubts, let me know. Then I'll start with your test. 2 questions are only there. Very easy 2 questions are there that you'll be able to complete before the given time. Note it down first. Text me done when you have completed the entire part. Okay, Abdullah. 2 minutes more, then I'll start with the test. I think Safura had also joined. Was she there? Safura, if you are not prepared with the center of mass because you had joined in the last class only, so you can leave the test, just take the screenshot of the question paper and you can send it as an assignment later on. If you are comfortable, just have just 2 questions are there. So if you think you'll be able to manage with it, then you can attempt the test. All right. So 2 minutes more class and I'll share the question paper on the screen. Yes, class. So switch on your cameras and please start with the test. So first question is there and this is second question. 5 marks each, 10-mark paper. Yes, Safura, you can leave.
Thank you, ma'am.
And others, you have started with the focus mode. So you'll not be having any difficulty with the recording and everything and regarding the video camera. So just switch on your camera and start with the test. Yes, class. So sufficient time was given for 2 questions. Submit your papers. Time is up. All of you submit your papers on WhatsApp.